देखो, one thing you should be clear that uh, there are two notations in NCRT. LMN, this here, these are called direction cosines. These are called direction cosines. LMN be the direction cosines. And ABC are called the direction ratios. So, in case, how are they connected? They are connected by this formula that that L is A this, M is this, where A, B, C are the direction ratios. So these are the direction ratios, and these are the direction cosines. These are the direction. Yeah, I'll come to that. I'll come to that. But direction cosines L, M, N are with for the are the angles cos alpha, cos beta of a unit vector. Unit vector. So they will always be less than one because they are cos theta values. These are and they add up equal to 1. But ABC will be greater than 1. So in case whenever you find that like here, obviously this is not a unit vector. So here B is direction ratios. And you can find the angle between two lines by both of them. You can use cos theta by using like there are two lines. You want the angle between them. I know the L1, L2, L1, M1, N1 of this, and L2, M2, N2 of this. Then I will find the angle, and we take more because we want the acute angle. And if you have direction ratios, then you will use this because L is nothing but this. L2 is nothing but A over this. Over this, so you multiply them, you'll get this. Similarly, b1, b2, and over these two. So this is, you can find angle between them using direction ratios or direction cosines. If the direction cosines are used, you will use this formula, or but in your it is this formula. Multiply. What we understand is that there are two forms of a line. One, the vector form in which a point is given and a parallel vector is given. A parallel vector given and a point is given. This is the vector form. This is the Cartesian form where A, B, C are the direction ratios. If they are greater than having magnitude 1, and if they are less than having magnitude 1, then they are the direction cosines. It doesn't make a difference. But this x1, y1 and z1 is the coordinate of the point, and this is the parallel vector. So these are the two forms for point and parallel uh, vector. And these are the two, if 2 points are given, x1 y1 and x2 y2, and for a general point, this is the equation, and this is the vector equation. Now this, how do you interpret this? You say that I can find the the position vector of any point if I know this vector, and by the triangle law, any parameter lambda which make me another vector which is a triangle and gets me this. So this is that lambda, and this is the Cartesian parametric. So if you got 2 points, you can just subtract them to get the direction ratio and put one here and get the parametric form. Now if they ask you to find the angle between two lines, you are going to do this. What are you essentially doing? You are, if there are two lines, one is has got a component of b1 as the parallel vector, another has a component of b2. Whatever is the angle between b1 and b2, that's the angle between the lines. So that's what he's doing. He's finding the scalar product b1 dot b2 of these two parallel vectors, and he's getting the angle between them. If you don't have, if you have if it's given in this parametric form, then you can just multiply the direction cosines or the direction ratios. But if you are using direction ratios, you'll have to use this a formula, not this formula. You can always convert this to unit vector and get the same thing. It's the same thing. Then we come to distance between lines. Acha.